Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video what I'm going to go through is BGP or Border Gateway Protocol Confederations. Now confederations is something that you may or may not see in a network, whether it be the enterprise, the data center, the service provider network, etc. You may or may not see them in BGP depending on the size of the network in the first place. But confederations do play a very significant role when it comes to these large autonomous systems, and they've got too many adjacencies actually being built that need to be maintained and that the routers actually need to keep track of. And confederations play a really big role in actually minimizing that. Now there's not a lot to actually go through with confederations because it is a very straightforward process, not only in terms of understanding what a confederation is, but also understanding from a juniper junos perspective how to actually configure a confederation in the junos world. And that's what we're going to go through in this video. First I'm just going to go through in the lab what is a confederation, why is it of benefit to an autonomous system, what's the logic behind it, and then of course how you can configure that in Juniper Junos. So enough said, let's just get straight on the lab. So what is a BGP confederation? Well, if we look at it from the EVNG, from a lab perspective, from a lab diagram, specifically let's look at it from Enterprise A or ASN 65100. Now as you can see, there's quite a lot of routers in Autonomous System 65100 or Enterprise A. We've got this router here, we've got this router here, we've got these three routers here, another three routers here, this router here, and this router here. So if I do the maths very quickly, that's actually 10 routers or multi-layer switches that are just within Enterprise A's environment. And if you know the calculation on how to calculate how many peerings or adjacencies you need, it's actually very simple. If you don't know what it is, I'm going to say in a second, but watch this video. It's a video done on BGP Route Reflectors where it's described there. But the formula is very simple. It's quite literally n in brackets n minus 1 divided by 2. N is the number of routers. So in this case that would be 10 in brackets 10 minus 1 divided by 2. And I know I'm going quite deep quite quickly, but if we just do this quickly, 10 with 10 minus 1 divided by 2, we then have 10 times 9 divided by 2 equals 45. So that means just in our Enterprise A, in Autonomous Systems 65100, all those 10 routers are going to have 45 adjacencies just within that autonomous system. But adjacencies to what? From what? Well, this all comes down to, and I've just changed the color of the writing pen just to make it a bit different. This all comes down to iBGP. Because this is inside Enterprise A's environment, inside the autonomous system, we need iBGP. And iBGP, by its very nature, requires a full mesh of connections, a full mesh of adjacencies. So if we look at it from this router here, it's going to have an adjacency here, it's going to have an adjacency there, it's going to have an adjacency over here, down to here, over there, and across to these three routers over there. And that's just for this one router here. So as you can see, just from one router, it gets very messy very, very quickly. Hence the need to have 45 connections, 45 adjacencies for all these 10 routers just in Enterprise A. That is one of the limitations around iBGP, and this is where the benefit of BGP confederations actually come into it. And what I've actually done from a lab diagram perspective is I've actually built two confederations. I've built this confederation here and I've built this confederation here. Obviously within these circles are the actual confederations themselves. Now what a confederation actually does is it breaks the autonomous system down into mini autonomous systems. So even though Enterprise A has this one autonomous system of ASN 65100, within that it's got two mini autonomous systems or confederations. We've got Confederation 65112 and down here we've got Confederation 65113 if I remember correctly. So the benefit of having these confederations is, if we look at it again from this router's perspective, it doesn't need to build adjacencies to all those routers in the confederation. It only needs to build a adjacency to this router here, to this router here, and to this router down here. That's it. And because I've configured these two routers here as route reflectors, if you don't know what a route reflector is, again, just refer to the video I referred to a few minutes ago. But because these are route reflectors, any routes that come into Enterprise A and are advertised down to this route reflector are then, guess what, reflected over to these other routers inside that confederation itself. So you can have route reflectors inside a confederation. But ultimately, what a confederation does is it breaks down that autonomous system into mini autonomous systems. But if we look at it from ASN1, ISP1, how does it actually view Enterprise A? I.e., can it see ASN 65100 and Confederation 65112 and Confederation 65113? The answer is no. Even ISP2, ISP3 and the Enterprise over here, all they see for Enterprise A is ASN 65100. They don't have any views into the Enterprise itself, into that autonomous system. So really this is all inside Enterprise A. It's all inside ASN 65100, and it's allowing the autonomous system to be divided into miniature autonomous systems, into parts as such, to prevent that limitation around iBGP where you need that full mesh connectivity. What you also need to be aware of is the BGP Path Selection process. If you don't know what that is, check out this link, or this link depending on which way it is on the video, but check out this link to understand more about the BGP Path Selection process. But here is the Juniper Junos path selection process for Border Gateway Protocol. So first at the very top, it's local preference. Really before that, it's next hop. The next hop has to be valid. It has to be reachable for it to actually go into the BGP routing table. And then it goes on to AS path. So typically the shortest AS path wins. It's just shorter. And then it will move on to lowest origin code. Has that prefix originated internally? Is it the source of the origin? Is it a question mark? Is it just unknown? And then it moves on to multi-exit discriminator and onto this one. I'm not going to go through them all, so on and so forth, until eventually it gets all the way down to here, number 9. Note here, cluster length. Now this is actually referring to confederations. So when I was saying that outside the autonomous system they don't see those confederations, no, they don't see the confederations, but they do see the cluster length, which is referencing the confederation number. So in the lab we've got confederation 65112 and 65113. If one of those routers in either one of those confederations actually advertises in a prefix into BGP, that confederation number will be carried within the update message of BGP and advertised throughout Enterprise A and into eBGP, and then outside of the world it goes. So it's very unlikely for a router to get all the way down here, because typically AS path, etc., is going to break that tiebreaker at such an early stage. But should it get down to the 9th stage, that router which has received the update message can actually see, well, are there any confederations? Are there any clusters? And typically it's like AS path. The shorter the cluster list, the more preferred that will be, and thus a cluster list of say 1111 and 2222 would be more preferred over a cluster length of 111, 2222 and 3333, just for example. Shortest paths always win, even with confederation numbers. And what you also need to be aware of from Enterprise A is every router is configured to have this ASN of 65100. But when it comes to actually configuring the ASN in the confederations themselves, in the routers inside the confederations, is that things do change quite differently. We don't define within the routing options the local autonomous system number to be 65100. No, what we actually do on these routers, just for example, is actually define that confederation number to be the local autonomous system number, and then we actually just reference this autonomous system number within the confederation itself. And basically what we're doing there is we're saying we are a confederation within 65112. You'll see this in the lab, but we are part of a wider autonomous system number 65100. And also there are other members within this confederation itself. But that's the configuration, and I'm going to go through that in Junos in just a minute. But what you just need to take away from this is that confederations allow you to minimize the amount of iBGP adjacencies that you actually need in an autonomous system itself. And additionally, it's part of that BGP Path Selection process. Yes, it's all the way down at the bottom, but it is there. It's very highly unlikely that it will get there because of the AS path, and maybe local preference is going to break that tie at such an early stage. But there's a final thing that you do need to be aware of. The final thing I want to point out before I show you the Junos configuration on how to build a confederation is we've got these route reflectors here, whatever the router numbers are, I can't remember. As you could see, they don't actually have a connection between each other. But what, for example, what if we wanted confederation 65113 to have a adjacency appearing directly to confederation 65112? Well, in such a case, we would actually build a connection to go from this router here all the way down to that router within that confederation at the bottom. However, when it comes to confederation, we are not using, you cannot define, it won't work, iBGP. You would actually need eBGP to build that adjacency site from this router here down to this router here. So we actually use an external BGP within the autonomous system. I know it's weird, but it's just how it's actually defined. But it gets even more interesting. Now with eBGP, like these routers here, this is an eBGP link. They build the adjacency using the physical interface's IP address, which can be questionable, I know. Because, or I should say, inside the autonomous system, between these confederations, we are building the eBGP adjacency to that loopback address. In Junos, there is only loopback 0, but we are actually building that adjacency, eBGP adjacency, to the loopback address. And I wrote it wrong there. It's actually loopback. Oh, I'm going to do that again. There we go. Looks a bit better. So to the loopback 0 dot whatever the sub interface is. And because we are building that eBGP adjacency to the loopback, you then need multi-hop actually configured. The reason why you need multi-hop configured is first the packets are going to go to the interface where you have that IP address, but then it needs to go to that router's loopback address, loopback 0. So you've got one hop here and you've got another hop here. So that's obviously 2 hops. eBGP is typically only defined to be 1 hop away. Hence, you must have the multi-hop command configured if you are building a eBGP peering between one confederation and the other, or another confederation. We're not going to do that here in this lab. I just want to show you how to configure confederations in the Juniper Junos world, and that's actually what we're going to do right now. Okay, so let's actually now start configuring these confederations in those 2 confederations themselves inside Enterprise A or Autonomous System 65100. But before I actually do that, I just want to take you through quickly what the setup is in terms of this lab. Now, as you can see, we've actually got Enterprise B over here, ASN 65200. And there's 4 routers in here. We've got R18, we've got R20, R21, and R19 here. Don't ask me why I've done it in that order. Honestly, I cannot remember. But what you do need to remember, just a little bit of information here, is that each one of these routers is injecting a /32 prefix into BGP. So for R18 there is an 18.18.18.18/32. For R19 there's a 19.19.19.19/32. For R20 there's a 20/32. For R21 there's a 21/32. You get the idea. Basically, these are static routes which I've imported into BGP. Now what's happening at that point is that these 2 egress routers in Enterprise B are advertising that 18/32, that 19/32, that 20/32, that 21/32. They're advertising out of Enterprise B into the service provider networks, where they are eventually go through ISP1, ISP2, ISP3, etc. And they eventually come into Enterprise A at these routers here. Now at this point it's all pre-configured. If you want to see any of these videos where this is all created in the past, just check out the BGP playlist. Here's a link. But these routes, these 18/32, 19/32, etc., are then advertised down to these route reflectors from those routers. So these route reflectors then receive those prefixes. But then we need the router here, and we're actually going to do configuration on this router and on this router here in Confederation 65112. We need to build the adjacency to and from these routers, and we need to build the confederation itself, and for those routes to be then advertised from that route reflector up to that router here. That is the goal. That is what we're actually going to achieve. So let's jump on Junos and actually start doing that now. And so I've just logged on to secure CRT on router R6. Actually, I want to go on to R7. So R7 is the one highlighted. Here is router R7. Nearly made a big mistake there. And let's just go into the command line interface, into configure mode, and it's going to edit routing options. Let's do a quick show, see what's there. Now you can see that there is a router ID. There's this random old autonomous system number 65101. No idea where that's come from, but we'll change that. That's fine. Now, how do we actually first go around building the confederation? Well, if you recall, I said that a confederation is simply a mini AS within the main autonomous system itself. The main autonomous system is 65100. It is Enterprise A. But this confederation, this mini AS, is 65112. So we actually need to define the autonomous system to be 65112. And let's do a quick show, and you can actually see the new autonomous system number there. So the next part is where we actually start building the confederation itself. So if I now define set confederation, if I hit question mark, you could see it's going to say, well, you need to give me a format. You need to give me a larger ASN number. This larger ASN is actually the autonomous system that the confederation actually belongs to. Confederation 65112 belongs to ASN 65100 because it's a mini AS inside of that larger AS itself. So now we actually define 65100, and at this point we now need to define the members. The members are all the other confederations that are within ASN 65100. Now in this lab diagram there's only two, 65112 and 65113. So that's all we need to enter. But if there's 4, 5, 10, however many, you'd need to enter in every single one of those confederations into this list. If you don't enter that confederation number into this members list and then you try to build an adjacency to it, it's not going to work regardless of how well you defined the BGP configuration. And the missing link will be the members list here. You've missed out the confederation member within this list. But to define the list, all we do is open up brackets and do 65112 and 65113. Close the bracket. Let's do a quick show. And now you can see this is the configuration. We've got our router ID for R7. We've got our autonomous system number 65112. Yes, this is the confederation number, but don't forget it's a mini AS. And here we are saying that we are a confederation of 65100. That is the large AS. That is the main autonomous system. And the members, the other confederation members within 65100 are 65112, which is who I am. That's who I belong to. But also another confederation member, 65113, whoever they may be from R7's perspective. They don't know. They don't care. Now, what we also now need to do is to define that BGP peering between R7 and that route reflector. So if I go to the top and edit protocols BGP and do a quick show, you can actually see here we've got this old group here, which to be honest, I'm just going to delete and we're going to start all over again. So let's delete this group. This is probably some testing I've done in the past. So now I need to define a new group. So I'm going to do set group, and I'm just going to call this internal 65112. And I'm going to say type internal neighbor, and I now need to define the loopback address of the route reflector. Now I haven't shown this, but I know this is 200.10.100.6. And if I do a quick show, it's looking pretty good. The final thing that I'm actually missing is I needed to define the local address. So I'm going to do set group internal 65112 local address, and this is going to be my loopback 0 address. So if I do 200.10.100.7, if you're wondering what that is the loopback 0 address. So if I do top edit and do show, you can actually see the loopback 0 address has 200.10.100.7/32, and I'm referencing that IP address here. And so basically within protocols BGP, I've built my group internal 65112, type internal, it's iBGP. I'm using my local loopback address, which has this IP address, and I will want to build an adjacency to 200.10.100.6. Now what I just want to check is actually, do I have the underlay protocol actually running? I haven't gone into this, but the underlay protocol is actually OSPF. So if I do top show protocols OSPF, and you can actually see it's configured here. And if I just do a quickly run show OSPF neighbor, you can see I've actually got a full adjacency to router R6 out of the GIGI 006 interface. And if I just do a show OSPF database, you can see we've actually got the loopback address of router R6 here. So that's great. And finally, let's just do a quick commit check. Make sure that configuration will pass. And it has, and so I'm just going to commit that configuration into that running database. Now at this point, let me just do top and quit. If I actually do a show BGP summary, you're going to see that this is active. It's not going to go any further because we haven't configured the route reflector. We've not configured the route reflector to have this adjacency to router R7. So we actually need to go onto router R6 and do that now. And so now I'm on the router R6, the route reflector. I've just highlighted it on the lab diagram so you know which one I'm referring to. Let's go into the command line interface, into configure mode, and again, let's go into routing options, do a quick show, and you can see the configuration here. Router ID and autonomous system 65100. Now at this point it's going to be a bit different. The reason why it's going to be a bit different is this route reflector has adjacencies outside of the confederation to these routers here, as well as to, or it will have adjacencies to routers inside of the confederation itself. So the adjacencies here are built using autonomous system number 65100. However, inside of the confederation, they're built using autonomous system number 65112. So we need to do things a bit differently on this router itself. So what I'm actually going to do is I'm actually going to leave the autonomous system number to 65100. There is a way to change this. I'll show you in just a minute's time, but we still need to configure that confederation member list. So I need to define confederation 65100 members, and as I did before, I opened up a list and I entered in 65112 and 65113, closed it off. Let's do a quick show, and that looks good. So I'm not changing the autonomous system number here, because if I do that, then the adjacencies to this router here and this router down here, they're going to break. It's going to be torn down because they're all expecting to have an adjacency, an iBGP adjacency to routers inside 65100. If I change this, it's going to tear the adjacency down. But then it's not going to work. If I keep this, it's not going to have the adjacency to routers inside the confederation. So this is the way you get about it. If I actually go now into top, edit, protocols, BGP, let's do a quick show. And here's the configuration from all the previous videos I've done. The group we're actually interested in is this group here, route reflector 66666. Now, to change that behavior I was just talking about, what I can do is do set group route reflector 66666, local autonomous system 65112. See what I've done there? And if I do a quick show again, you can now see that that local autonomous system has been added. Now this is important because what we have within the routing options is the local AS defined to be 65100, but we've also defined our Confederation members list. That is important because then within this group at the BGP, the iBGP level, we're overriding that routing options AS with this local AS is 65112. We're overriding it. So this really no longer exists. It still exists for these neighbors here, which is the adjacency from this router to that router, from the route reflector down to this router here. And thus we're able to have those adjacencies outside of the network and into the confederation itself. And the screen has just got very, very messy very quickly. But if I just do a quick commit check on this, and it succeeds. Now, before I actually commit that, I just want to go back onto router R7. Let's get a bit of space and just do a show route. Let's actually see what route it's got in the routing table. So it doesn't see this 18/32. This 19/32, this 20/32, that 21/32, all those prefixes which have been advertised way over in enterprise, being advertised through the service provider networks and into enterprise A. It doesn't see them yet because we don't have that adjacency built yet to the route reflector. Now hopefully when I commit the configuration on router R6 now, that will change. I might need a next hop self policy, but we'll see. So if I just commit the configuration, and I always do this, I should have gone top and it's quit. And now let's check the BGP summary. Let's make sure I've got the adjacency. So I've got adjacency still to router R5, to router R8, to router R9 is actually actively trying, and same to router R7. Sometimes it does take a few seconds, so let's just give it a bit longer. So you can actually see it's established the adjacency to router R7. I'm going to have to look into what's happening on router R9 within the confederation, but that's a separate topic. But 200.10.100.7, that is router R7, and we've built the adjacency to that router. Are we advertising prefixes to those? So if I actually do a show route advertising protocol BGP to the neighbor 200.10.100.7, we can now see we are advertising the 18/32, the 19/32, the 20/32, and the 21/32. So the route reflector is advertising them. If R7 has not got these routes installed in the routing table, at this point it is going to be a next hop self policy which is needed. But let's go on to router R7. Let's get a bit of space and do the same command again, show route, and yet as I thought it is a next hop self policy. Okay, and so what I've done is just quickly is I configured a new policy statement called advertise route reflector for all protocols from BGP, the 18/32, the 19/32, the 20/32, the 21/32, and these networks are longer in between. I've said I want to accept these and put these as next hop self. And then I've actually taken that policy statement called advertise RR, route reflector, and exported that into that group. So basically what the route reflector is doing is saying if you want to get to all these networks, these 18/32, the 19/32, etc. If you want to get to them, you have to R7, R8, and R9. You have to come through me. I'm the next hop to get there, and it's advertising that via iBGP into the confederation. So now the test actually is if I actually just do a show route again, you can now see here's the 18/32, the 19/32, the 20/32, and the 21/32. Note it is advertised from 200.10.100.6. That is the route reflector. So in summary, that is how very quickly you configure confederations in Juniper Junos. Depending on your architecture does decide, as you can see, how you actually configure that, but really it's the same. You've got to configure the confederation, Then you define the main autonomous system, in this case ASN 65100, and then you define all the members, the list of all confederations within that autonomous system, all the mini ASs within that autonomous system. Remember, if you want to build peering from one confederation to another, you have to have every single one of those confederation ASNs defined within that member list, otherwise it will not work. And so that is it, everybody. That is how you can configure BGP confederations in the Juniper Junos world. Confederations, in short, in summary, are very simple in terms of what they do. They keep down the amount of iBGP peering or adjacencies that you need within that autonomous system. It essentially creates, as I've been calling them, mini ASs, mini autonomous systems within that main autonomous system itself. Also, in terms of the configuration, you do have to define, yes, your autonomous system number within the routing options, but what is absolutely important is you then define the set confederation, you define the main ASN at that point, 65100 as we saw, and then you define all the members, all those mini ASs that are within the autonomous system itself. So again, I hope you found that useful, hope you found that informative. If you like my video, if you like my content, please give it a like. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. I do love hearing from you all. Other than that, thanks for watching and stay tuned for more.